Conway's game of life is a famous example of a cellular automaton. It takes a discrete grid of cells where each cell is either dead or alive and forms each subsequent generation based on the population of their neighbouring cells. The rules are, if a cell is alive, it remains so as long as it has 2 or 3 live neighbours. If a cell is dead, it can become alive only when it has exactly 3 live neighbours. In our version of this, the game of light, real Volvox algae cells interact with cells simulated by Conway's game of life through an augmented reality layer of projected light. Using a system called the Dome, we are able to combine real-time image analysis with digital light processing technology to facilitate interactions between the algae and light patterns. The position of each Volvox cell is fed into the simulation for each generation, meaning that a neighbour cell may be either an artificial cell of light or a living Volvox cell. The result is a hybrid of artificial and real life. The addition of this reality layer to Conway's game of life means that where stable shapes are formed, interactions with moving cells can interrupt this stability to produce new dynamic patterns. Here, a previously stable square becomes dynamic once again after interaction with a moving cell. We can use the real cells to seed the game of light. The first artificial light cell is born where 3 Volvox are within close proximity to each other. This means that all living cells, both real and artificial, are descendants of these Volvox. The game of light demonstrates how artificial life can be layered with real systems, producing a mixed reality where the virtual and the living may interact.